Hello, flippers. This is video 3.2. The unit title is stop motion animation, and the objective is I can identify properties of medians and altitudes of a triangle. And your IXL skill is M3. All right, let's go, flippers. All right, so the first thing we want to talk about today is the median of a triangle. So the median of a triangle is a segment whose endpoints are a vertex and the midpoint of the opposite side. So let's look at these two triangles here, triangle ABC and triangle DEF, and let's actually draw in a median. All right, so here is triangle ABC, and if we look at it, we can see that we have a median drawn in from A to side BC. And we know it's the median because it comes from the vertex A, and it goes across to BC, and it splits it into two equal pieces. So it's split into two equal pieces, so let's label that point D. And now we can make a statement that BD, segment BD, okay, is going to be congruent to segment DC. And this happens a lot in IXL when you're working on that skill that you have to do, M3. Okay, so here now I've drawn in the other two medians. So here is the red one that goes from point B all the way across to segment AC, and we're going to add in a point here, and we'll call that E. And then we've drawn in the other median, which goes from vertex C all the way to AB, and we'll add a point there of F. So what's really cool is that you're going to notice right away that there's a cool point of intersection between the three medians. This is a very important point that you're going to find out about very soon, but not this lesson. But it is true that all three medians intersect. Okay? Notice that the markings on the triangle here, triangle ABC, that FB is congruent to AF, but AF is not necessarily congruent to AE, okay? These segments are being split into two equal pieces, but they don't equal to each other, so that's very important. So BD is not necessarily congruent to EC. It might be, but we don't know that for sure. But we do know that BD is congruent to DC, AE is congruent to EC, and AF is congruent to FB. That is a certainty. Let's try it for DEF over here. So there we have another triangle, triangle DEF, where we've drawn in all of the medians that go from the vertex to the side opposites midpoint for this particular triangle. So make sure, again, you're drawing this and you have both examples. So it's a really good thing to understand, and if you think about it, that a triangle is three medians, so the three medians that we have, since they're intersecting at a point, they're always going to be concurrent. And that just basically means that these three lines intersect at one point. So they're concurrent. All right, so let's talk about a special property that happens with medians. Okay? So this statement says, the section of the median nearest the vertex is twice as long as the section near the midpoint of the triangle's side. What? So basically what that means is, let's look at this triangle here again, okay? Triangle ABC. That statement means that if we look at the point of intersection for triangle ABC, let's name it, let's call it M. Okay? What this statement that I just read basically means is that FM, okay, is going to actually be 1/3. So it is equal to 1/3 of FC. So what that translates to is the small section of the median is equal to 1/3 of the entire thing. Hey, so that means that another statement we could write would be that MC is equal to 2/3 of FC. And that is pretty darn cool. This example at the bottom is just one for you to draw. We'll have this be triangle VT, let's name it S. And this is an example of a median because it's going from the vertex across to the opposite side, and seeing that these two segments are 13, we could write that segment VU is congruent to segment UT. So now we're on to the altitude of a triangle. So the altitude of a triangle is the perpendicular segment from a vertex of a triangle to the line containing the opposite side. So let's focus in on this triangle here. And this is triangle YVX, okay? So it is the perpendicular segment from a vertex. So we start at the vertex, start at Y, and we go to the line opposite, but we go across so that we create a perpendicular right angle there. Yes, we do. So let's see if we can do this for the two other vertexes in the triangle. Since we have one of the altitudes drawn, which we've already said and stated here is YW, the other two altitudes we can draw in. So let's draw them in. So it won't surprise you that XY is actually an altitude. Why? Because this is a right angle. And YV is also an altitude because this is, we just talked about it, a right angle, and it's going from the vertex perpendicular across, okay? So what happens is you will see we have a point of intersection here between the three altitudes. Let's try this again for an acute triangle. Here's an acute triangle, and we're going to draw in the altitudes. Remember, it has to go from vertex to the side opposite, and it's got to be making a perpendicular segment. So I'm going to start here. I'm going to say this is A, B, and C, and I'm going to go from vertex A across to BC. And here I go, right across, and this is perpendicular. So there's a perpendicular line there. And then I'm going to go from vertex C. So here I'm going across, perpendicular. You're probably wondering, how are these perpendicular, Marla? Because I'm psychic. No, I'm psychic, but I'm just telling you they're perpendicular. So there's a perpendicular line there. And then I'm going to go from vertex B, and we're going to go down. And here, this is perpendicular. So now, again, you see that there is a point of intersection here. Last example that we're going to look at, triangle DFG, is an obtuse triangle, okay? So we're going to draw in, again, the three altitudes. So let's use green, okay? So we're going to start with the obtuse angle. And again, you're going across so that you're making a perpendicular line. Perpendicular segment. So here we have our first one. Our second one, which is going to be weird for some of you, is actually going to be outside of the triangle. Right? It has to be. It has to form a 90-degree angle. And there it is. So what you imagine is you're extending segment GF out. Okay? And then last but not least, we're going to make the one from F. And again, this one is also going to come from the outside. There we go. And imagine that we extended the triangle here. Imagine it was extended. Imagine that was extension. Okay? So we have these three altitudes. One here, and then this one, if we extend it out more, you will see it intersects. And unlike example 1, example 2, and example 3, the obtuse triangles altitudes intersect on the outside of the triangle. Whereas the altitude of an acute triangle is inside, and for a right triangle, the intersection is inside as well. Recall that perpendicular bisectors bisect a segment at a right angle. So remember, this is something you're going to have to do with IXL, remembering that that is going to happen. And then angle bisectors actually bisect an angle. So you're always going to see markings indicating that the angle has been bisected, like little markings like this. Same thing for perpendicular bisectors, just backtracking a little bit here. If I've got a perpendicular bisector, then when it comes across and it's perpendicular, it's going to be perpendicular, but the two segments are going to be congruent as well because it's bisecting. All right? And again, bisecting. All right. So these are different than medians though, right? Because medians don't have to be perpendicular. I never said it had to be perpendicular. And altitudes don't bisect anything. They're just altitudes. We just looked at them. We didn't put any actually congruent marks. We just put in right angles. example number 1. It says, in which triangle do the 3 altitudes intersect outside the triangle? A right angle, an acute angle, or an obtuse angle? Well, we just looked at this, and it was an obtuse triangle. So when you come in class tomorrow, you need to have those examples that I did in the video done. Please make sure you do. Number 2 says, triangle ABC has vertices 3, 3, that's point A, B is 7, 9, C is 11, 3, and they want you to determine the point of intersection of the medians and state their coordinates. So in order to do this problem, the first thing you have to understand is that you need the midpoints of all the segments. So I need the midpoint of segment AB, BC, and AC. So you can actually make medians, because remember, medians go from vertex to the midpoint, vertex to the midpoint, vertex to the midpoint, okay? So what I did is I found the midpoint of all the segments. So the midpoint of AB is 5, 6, BC is 9, 6, and AC is 7, 3. So let's graph those points after you've graphed the triangle. Now I've graphed all the midpoints of the segments, and I'm going to draw my medians. So let's use green. So here is the first median. Here's the second median, and the third one, and yes, they do intersect. Ta-da! And it said to state their coordinates, and we've done that as well. So we're done. And here is the secret hot question. The secret hot question is, look at the diagram. Which term describes PR? Segment PR. Notice that SR is 85. Notice that RQ is 58. Is it a median? Is it a perpendicular bisector? Is it an altitude, or none of the above? Remember, your IXL skill tonight is M3. See you later.